Kart City Racing is a game I'm developing in Unity for my college computer science capstone project. It is a kart racing game that takes the controls and gameplay from games like Mario Kart and merges them with the open world aspects of games like Burnout Paradise. Mario Kart is a Nintendo racing game series where you play as various Nintendo characters, ranging from Mario to Link to Kirby and more. In it, you race around in colorful go-karts on crazy tracks themed after various Mario games and levels. What we want to do is recreate this general gameplay. Burnout Paradise is an open-world racing game where all the events take place on one continuous map. This means that the player can explore this map outside of races or events to find collectibles or to just mess around. They can then drive up to any intersection, and with the press of a button, they are off on a race. All races take place on the exact same map as the one they explore, so the knowledge they gain from exploration helps them in the race, and the knowledge from a race helps in exploration. We want to use this exact same open world format. Now that I have explained both of them, let's take a look at the actual game we have at the moment. So here you can see the main menu for the game, where you can just play and load up. And now we are in a open world environment. Notably, we are not in a race, but the player is free to explore and drive around at the moment. But if we come up to an intersection or the circle up ahead, and with the single press of a button,
This is a time trial. Race to the north gate as fast as you can.
we are now starting a race. We are showing a little intro, hearing countdown right now, and we are off. Now, at the moment, the game does not really clearly tell the player where to go, but me as the developer, I know exactly where to go. Notice how we were on the exact same map, so we were taking that layout or gameplay from Burnout Paradise of using the same map for the races and exploration. Now I happen to know if I drive right through this, there, I finished the race right there, and with the press of the continue button, we will be right back where we were on the exact same map. I ignore the part where it basically happens to have fallen off the map, but as you can see, we are taking the open world elements from Burnout Paradise and the controls from Mario Kart, as you saw a little character design from there, and using that in the same game. And while I could stop this presentation right there, since this is for a computer science capstone project, I feel I should spend some time going over the major systems at work. This is roughly all the main systems, classes, or key actors in this project. Let's go through them. Let's start on the bottom right. Starting on the left, we have the character class. This class acts as both a wrapper and a facade type class for many of the components that make up what we would think of as a character. The character class is designed with the assumption that it could be controlled by both a human player or an AI robot. Below the character class is the camera manager class. This class controls the camera and its current state. Most of the time, this is behind the human player's character, but during a race intro, this changes to a static wide angle. I also plan on having it change when the race ends as well. At the moment, it doesn't. Moving to the right of that, we find three subclasses that the character class has: vehicles, items, and the driver model. The item class hasn't been fully implemented at the time of writing, but will act as the root class for any held items the character has. The driver model class handles the animations for the driver in a given vehicle. At the moment, the animations haven't been made, but when they are, this class will handle those animations. The vehicle class handles the actual movement of the vehicle the user is driving. One feature we have added is the ability to switch between cars and boats on the fly during a race. While the cars use wheels to move on static ground, the boats need some waves to float on. These waves use a custom shader function, allowing them to run on the GPU for better performance. However, the boat code is on the CPU. So the Wave Manager class acts as a bridge between both. It sends the main wave variables to the GPU once at the start of the scene, then acts as a system the boat can query to get the current wave information to appear to float on top of the waves. Lastly, these waves use Gerstner waves rather than simple sine waves to give them a more realistic appearance. Moving next to the bottom left, we have the controller classes. Game Controller is a generic parent class that lets us or anyone control a character. Derived from that, we have the player controller and AI controller child classes. This allows us to set what exact actions an AI or human player is allowed to take. For example, a human player is allowed to pause the game, and AI is not. Lastly, we have the input mapper and AI brain classes that interact with the AI controllers and player controllers, respectively. Input mapper is what actually maps the buttons on the keyboard, gamepad, or whatever you end up using to the actions in the game. Unity actually handles most of this out of the box. The AI brain is where all the AI logic will go. At the time of writing, I have not implemented any AIs, but this is how they will fit into the rest of the systems. After the controllers, the two systems I want to touch on next may seem unrelated at first, but those are the save system and the UI system. The save system is incredibly straightforward. It saves the user's progress in a save class that gets written to and read from a file on the device. The UI or user interface can be broken up into multiple widgets. Each of these widgets gets loaded in or unloaded as needed. This is handled by the UI Widget Manager class. These widgets also need data that can come from just about any system in the game, but we don't want to create a bunch of dependencies between all the individual widgets and the rest of the code. This is where the UI Blackboard comes in. The Item Widget class displays the currently held item. This means it has to know what that item is. The Character class knows what that item is and can post it to the Blackboard. The Item widget can then read this from the Blackboard and display the correct image. It can even subscribe to be notified when this data changes. Since every UI widget subscribes to the same Blackboard, this method scales much better than creating a bunch of disparate dependencies between various widgets and systems, since there is one in-between system, the Blackboard. This Blackboard design pattern is also used in the save system in the save class. This lets us make the save class once, and then later on in development, we can keep posting more and more different types of data to the save class without needing to refactor it at all. Under the hood, all this Blackboard is a dictionary with a generic value type. Technically, this code does not compile in C#, the language we are using. But we can make a dictionary of objects and then fill that object with a generic class that just contains a generic value. The last systems we will look at are the red in the top left corner. The Game Manager class is the highest level class in the entire project and handles functionality we need persistent for the entire game. At the moment, all it does is load and unload game mode classes, which act as top-level manager classes for the modes the game can be in. The race class has a subclass that contains all the static data of the race it will start at the moment. This can be things like types, goals, etc. The majority of the work done by these game mode classes is loading and unloading the assets needed at key events, like when a race starts or ends. And that's all the major systems in this project. The next main things I want to focus on in this game are juice. That is, the polish and visual fidelity of the art in the game. Even though this is a computer science capstone project, and I will mostly be grading on my computer science and coding skills, I still feel that as a game, the importance of quality is incredibly important for the feel and final product. AI is the other big thing I want to tackle next. It is not really a racing game without opponents that you can race against. I've already given some thought into how I will include these into my system as demonstrated earlier, I just have not gotten to implementing them yet. If you want to play the game for yourself, or check out any future builds I make, you can just scan this QR code. It will take you to itch.io, a site I am using to post the latest builds of the game. Feel free to leave any feedback or report any bugs inside the game itself. And that's it for my midterm devlog. I'll be back again in December for the final presentation. Hope to see you then.